Let's turn our attention to trigonometric equations where the argument, that thing that we are taking the sine of or the cosine of or the tangent of, what happens when that argument is not just theta, but some multiple of theta, like 5 theta or 3 theta. So let's look at this example where we have an equation 2 sine of 3 theta equals 1. Let's isolate the sine function. So let's divide both sides by 2. So this yields sine of 3 theta equals 1/2. Now we don't need the parentheses around the 3 theta because that's just multiplication of theta by 3, but it might emphasize the fact that we cannot divide by 3 here and cancel. Instead, what we have to do is let's treat this 3 theta as our angle. Now sine of what angle yields 1/2? So the reference angle is going to be pi over 6 because I know the sine of pi over 6 is 1/2. Now this could be in quadrant 1 because sine is positive in quadrant 1 or in quadrant 2. So if we're in quadrant 1, what could our angle be? Pi over 6, but it could be coterminal with pi over 6, so it could be pi over 6 plus 2 pi k. But what is our angle here? Our angle isn't theta. Our angle is 3 theta. So therefore, 3 theta can be pi over 6 plus 2 pi k. So now, again, we're solving this for theta, so let's divide everything by 3. So theta equals, now pi 6th divided by 3 is pi over 18 plus 2 pi over 3k. Now I could put the k in the numerator also, but the reason why I've not done that here is we have 2 pi over 3 times k. Go back to your original trig function. We have sine of 3 theta. What is the period of sine of 3 theta? Well, the period of the original sine function, just sine of x, or sine of theta, or sine of alpha, that period is 2 pi. But we have horizontally compressed it by a factor of 3. So the period of this sine function would be 2 pi over 3, which is exactly what we see here. Now, let's look at our second quadrant. Our angle, 3 theta, could equal an angle in the second quadrant with a reference angle of pi over 6 would be 5 pi over 6. But then again, we could add to that any number of revolutions, so 2 pi k. And again, divide by 3. So we would have theta equals 5 pi over 18 plus 2 pi over 3 times k. And so there is your answer, where k is an integer. Now let's look at secant of 4 theta equals 2. So you might think, just to yourself, we know, maybe we don't know secant functions very well, but we know the reciprocal cosine of an angle would be 1/2 in this situation. So we have cosine of 4 theta equals 1/2, or secant of 4 theta equals 2. What's the reference angle? The reference angle would be pi over 3. So let's look at where secant functions are positive, and that would be in quadrant 1 or in quadrant 4. So in quadrant 1, our angle 4 theta would equal pi over 3, our angle in the first quadrant, plus 2 pi k, which means that if I divide everything by 4, I would have pi over 12 plus, now 2 pi divided by 4 would be pi over 2k. Now again, if we pause for a moment, the period of a secant function, of our parent function, secant of theta, is 2 pi. But if we divide that by 4, because the function has been compressed horizontally by a factor of 4, we would have 2 pi divided by 4, or simply pi over 2. Now, as we look at our quadrant 4 angle, 4 theta would equal, now pi over 3, represented in the fourth quadrant, would be 5 pi over 3. In case you're still having difficulty thinking through that, I am looking at 2 pi and I'm backing up pi over 3. So if I remember that 2 pi is what over 3? 6 pi over 3. And then back it up, pi over 3 would be 5 pi over 3. And then I would add to this 2 pi k. So theta equals 5 pi over 12 plus pi over 2 k. And there is your solution for theta. In this example, we'll look at a tangent function. So again, let's isolate our tangent function by subtracting 1 from both sides. And so this will be negative tangent of theta over 2 equals negative 1. Now we can divide both sides by negative 1, and we have tangent of theta over 2 equals positive 1. Now, where is tangent of an angle equal to 1? So again, we're ignoring theta over 2. What is the reference angle here? The reference angle will be pi over 4, and we're looking at quadrants 1 and 3 because tangent is positive in those two quadrants. And here remember that the tangent function, you can look at quadrants 1 and 3 and they're only going to be separated by pi units. So theta over 2 will be our reference angle plus pi k. So I can multiply both sides by 2 and we have theta equals pi over 2 plus 2 pi k. Now how do we see the period of our function represented in this answer? Here I see 2 pi times k. Where did the 2 pi come from in terms of our period? So you'll remember that the period of the tangent function is typically pi, but this has been horizontally stretched by a factor of 2. So we take pi and we divide by a half. Where'd the half come from? This is tangent of 1/2 of theta. So this will be 2 pi. And that is where the 2 pi comes from. So our answer is simply pi over 2 plus 2 pi k.